Hello, I am Álvaro Iradier from Sysdig. Thank you for assisting to this talk, where I'm going to tell you about my experience while implementing OpenID Connect as a single sign-on solution in complex environments. So, the agenda for this talk will be single sign-on basics. Let's see some concepts. Then, what is OpenID Connect? We will see some typical flow examples. How OpenID Connect is similar, different, or what shares from other concepts like SAML, OAuth, etc. Why use OpenID Connect? Let's talk about some reasons. Then we will do a demo on testing and debugging OIDC. We will create an OIDC client, and then I'll share with you a real-world example on how to deal with complex authentication scenarios. I'll talk about other caveats found in our trip, and finally, the good, the bad, and the ugly about OpenID Connect before moving to questions. So, what does single sign-on mean? It's a very broad concept. One definition could be the one in the slide. So, allow users use a single set of login credentials for multiple applications which can be related, but they are usually independent. Why? Because users have to remember less passwords and no need to re-enter them on every application. For security, you lessen the chances of phishing and reduce password fatigue, and also reduce password issues for IT help desk. And why not? Well, there is a higher risk for exposed credentials. If your credentials are exposed, all the applications are exposed. So you should increase the focus on protection, for example, using multi-factor authentication. And also, you turn the single authentication into a single point of failure. So if it fails, all your applications will fail. Well, and what is OpenID Connect? Well, basically it is an identity layer on top of OAuth 2.0 protocol to verify identity delegated to an authorization server. So it allows you to obtain end-user basic profile information in an interoperable REST JSON manner compatible with web, JavaScript, mobile apps, etc. Basically, it lets the application side developers authenticate users without taking on the responsibility of storing and managing the passwords in the face of an internet that is well populated with people trying to compromise your user's account for their own gain. The OpenID provider can handle the users and passwords, and it can delegate to directory services, or it can act as a hub of other providers, let them be OpenID, SAML, etc. Example OpenID providers are Google Sign-in, Microsoft, and many others. Let's also introduce some OpenID terminology, like the OP, the OpenID provider, which is the server that performs the authentication as a service, sometimes also called IDP, Identity Provider, and the relying party, RP, or simply the client, which outsources the user authentication to an OP. Don't confuse the client, the relying party, with the user. The relying party or client uses the OP to authenticate the user. So OIDC works by a set of interactions between the user agent, that is the browser, and the server or backend, and the OpenID provider. This is what we define as a flow. It works on top of OAuth 2, so if you're familiar with it, you might already know there are different flows. Why? This, in the slide, is the authorization code run flow, where the client is registered in the OpenID provider, and it can safely store and keep a client ID and client secret, which is used to authenticate the client with the provider. This flow is typically used by web applications where the client is a backend server. Let's explain it step by step, and I'll try to be brief and skip some details, as I expect some of you are already familiar. So first, the interaction is just between the user and the website through the browser. The user opens a site, the backend sends some HTML rendered by the browser. The user is not logged in, so it clicks the login using OpenID Connect button, for example, using Google as an OpenID provider. That request causes the backend to redirect the user to the authorization endpoint of the OpenID provider. And here is where the OAuth or OpenID Connect dance begins. In this part of the flow, the user interacts with the OpenID provider to get authenticated. The redirection causes a GET request to the authorized endpoint of the OpenID provider and includes several mandatory parameters. The response type code tells the provider to reply with an authorization code via a callback. The redirect URI is the URL of the callback where the authorization code will be sent. The client ID identifies the client which must be previously registered in the provider, including a list of authorized callback URLs. And the scope parameter must always include at least the value OpenID. There are other parameters like state nonce to prevent cross-site request forgery, replay attacks, and scope can include email, profile, and others to get additional user information. At this point, the OpenID provider must authenticate the user by any means. It can be a valid session cookie if the user was previously logged in. It can ask for a user password, use multi-factor authentication. It can delegate to another identity provider, etc. The OpenID provider might also ask the user to keep the consent to access its identity information to the client application. This is the typical confirmation dialog to allow application whatever to access your personal information. If everything is okay, the web server, the backend, now receives the authorization code as a GET callback request. The state parameter is also included so it can be verified. Now, and this is the characteristic feature of the authorization grant code flow, the backend now talks directly to the OP to exchange the received code. It sends a POST request to the OP and includes the code received in the callback, the client ID, and the client secret. The response of the POST request is a JSON document including the ID token, which is a signed document verifying the user identity and other information, and also an OAuth token and a refresh token. The server must in here verify the ID token signature using PKI and the OP provider public key. Furthermore, the access token can be used from the client to call the user info endpoint and retrieve additional information. Now the user is logged in, and the backend can serve the front page for the logged user with a welcome message or whatever. Okay, the problem with the code flow is that it requires a server or backend application, which can store safely the client secret. And this is not valid for some single-page applications or mobile applications which run the client, and the secret could be exposed by checking the code, the compiling, etc. For these cases, there exists a different flow, the implicit flow, which is used. Let's briefly explain it. The flow begins exactly the same. Instead of a single-page application in the browser, here we could have a mobile application or a desktop application. The user requests the application to log in with OpenID Connect. Okay, again, this is translated into a GET request to the authorized endpoint of the OpenID provider with similar parameters as the previous flow, but this is different. The response type is token ID space ID token instead of code. That requests the OpenID provider the access to send the access token and the ID token in the callback to the application. Again, in this step, the OpenID provider authenticates the user with any mean. And once the user is correctly authenticated, in the implicit flow, the callback now includes the access token and the ID token as part of the callback URL. There is no need for the additional exchange step that was in the code grant flow. So now the application has the ID token to verify the identity and could use the access token to request additional information. Okay, if our goal is just having a unified sign-on experience, then there exist other options. You could simply have a shared user DB or a directory service like LDAP, so the user only has one username and password shared between all the applications. However, this might require exposing the directory to the internet for public applications, and if you are reusing credentials, but the user needs to re-authenticate on every application. So we don't have a real single sign-on. You could also use hardware-based solutions like smart cards, but you need to support that in the application, which is not easy. Like OpenID Connect, there are also other token-based solutions where you obtain a token, which is the proof of identity. For example, multiple web applications under the same domain could share a session cookie, so you authenticate once and you are logged in all the applications. Or Kerberos or other ticket granting systems authenticate the user and obtain a token that is later used as a proof of identity to access additional services. Facebook Connect, also known as Login with Facebook, is very similar to OpenID Connect, but it is tied to this company, so you must trust Facebook, and you might find connectivity restriction in some countries or some environments. Security Assertion Markup Language, or SAML, is another protocol which serves the same purpose as OpenID Connect. It is older, based on SOAP and XML documents, and it is mainly designed for web applications with a backend server. So it's not well suited for other application types. But apart from that, it is still a valid and working standard. I won't extend more into the differences. You can find some of them in the slide. So OpenID Connect should not be confused with OpenID 1 and OpenID 2, which are obsolete and predecessor protocols. OpenID started back in 2005 as a protocol to provide identity certificates, and version 2.0 was widely adopted, but it is now deprecated. OpenID Connect is the third generation, and it dates from 2014. It is much more developer-friendly and broadly used. And how does OpenID Connect compare to OAuth 2? Well, OpenID Connect is built on top of OAuth 2, but OAuth 2 deals with authorization, not with authentication. What is the difference? For example, if Stack Overflow wants to post in Facebook, the user authorizes Stack Overflow using OAuth. Stack Overflow obtains an access token and uses that access token to post using the Facebook API. That is authorization. But if Stack Overflow only allows to comment if your reputation is above 50 points, for example, then authorization in this case is done in Stack Overflow. But Stack Overflow can check the user, can delegate the authentication to a provider. For example, it can ask Google to identify the user using OAuth 2. Stack Overflow obtains the access token, uses the access token to obtain the user identity, for example, the email, and with the email, it can check the user reputation and authorize the user locally. So OAuth 2 is about getting keys for accessing something. OAuth 2 can be used as a pseudo authentication mechanism in the sense that if you give me a key to access your apartment, probably you are the apartment owner, but the key itself doesn't prove your identity. So in OpenID, the key provides access to a document certifying your identity by adding the ID token and a user info endpoint to OAuth 2. So some people call this abusing the standard OAuth 2 protocol. And how is OpenID Connect related to JSON Web Tokens? Well, OpenID Connect uses JSON Web Tokens as the signed document that contains claims about the user identity. You can use some tools like jwt.io to decode and verify the tokens, as we will see shortly. So why use OpenID Connect? Mainly because it is easy, reliable, secure, and lets you get out of the difficult and dangerous business of storing and managing other people's credentials. It also makes users' lives easier during sign-up and registration. Some strengths of OpenID Connect are shown in the slide, like it is interoperable, secure, easy to deploy, flexible, wide support devices, and so on. So which protocol should you use? Probably if you are developing a mobile application or writing a new application, you should use OIDC. In which cases, for example, if you have an application which only supports SAML and the identity provider supports SAML, then probably you must stick with SAML. No need to reinvent the wheel in here. Okay, now I'll show you some useful tools to help you debug OIDC issues on how it works. They are listed in here, and we will see a couple of them in the demo. And also the browser network console can be very useful to check what is happening, or some command line utilities like curl. For this demo, the prerequisites is you need an OpenID Connect provider where you have a client registered, you have a client ID and a client secret, you have allowed the redirect URIs in the provider, and then in the client, you know the endpoint of the OpenID provider. So let's see a demo using OpenIDConnect.net and OIDC debugger. So in this demo, what I have done is I have entered the configuration of an OpenID provider with the client ID, client secret, and this shows me the request. I'll open the network console to check what is happening. And when I click start, I'm going to send a GET request to the OP provider, which we will see in the browser. And this will trigger the authentication in the OpenID provider. So this was the call to the authenticate endpoint. the information, the client ID and the parameters are in there. Now I enter my credentials in the OpenID provider. And when I click login, I can see there is a callback, right? The OpenID provider is calling the callback endpoint, the redirect URI, providing the authentication code in there. So the next step, we are using the authentication code flow in here, is send a post request from the backend to the OIDC provider to exchange that code with the ID token and the access token. So that is the response. You can see the ID token. So now in the following step, you can take that ID token and you can copy it and use a tool like jwt.io. You paste the token in here and you can see the code information, the signature, and so on. This tool already does that. So if you just click verify, you can see the token is valid and the information. This was the code flow. Now we will check the implicit flow. So using OIDC debugger, again, I have configured the OpenID provider in the credentials in there. And now what I'm going to do is in the response type, I'm removing the code and keeping token and ID token. So this is the implicit flow. This is the get request that we will send. You see in the response type, we have token, blank ID token. And when we send this, we can check in the network console, we are going, well, this time, as I was already logged in the OP provider, it didn't ask me for authentication. You can see the response type in the callback, and you can see that the callback now directly includes the ID token in the URL. So the application can directly get the token from the URL. Okay, and some details of the GET request. Okay, this was the demo. Let me move on. So OpenID is a simple protocol, OpenID Connect, so it can be implemented from scratch, but this is usually not necessary, as there are plenty of available libraries, some of them certified, for implementing relying party clients in multiple languages, or to implement different OpenID Connect servers and services. Let's see a Python example using the Flask framework. So I won't go too much into the details, but basically we declare some dependencies for Flask, request, and auth-div, which is the library implementing OpenID Connect. And in the server code, we do some imports and create an auth0 object with the client parameters in the code in the right. We need to handle the callback from the OpenID provider once the user is authenticated. This is what this function does. When we get the callback, we call auth0.authorizeAccessToken, which will automatically exchange the received code with the ID token and the access token. This library already handles the ID token verification and decoding and provides an easy way to access the user info. So finally, after the callback, we redirect the user to the dashboard page. We create a login page, very simple, just a login button that takes you to the /login route, which starts the OpenID Connect dance by redirecting the user to the OpenID provider. You can see the view and the controller. Okay, finally, our dashboard implementation is just a welcome message in HTML and the JSON user information printed in raw. And the dashboard route or the dashboard controller uses the requires out decorator to make sure that the user is logged in, or otherwise it redirects it to the login page. So this was a simple application using OpenID Connect. Really simple. Now let's move to a real world example. Nearly all I know about OpenID Connect was learned during the migration of a set of tools from this internal data center you see in the diagram at the top left to cloud infrastructure. Previously, most of our tools were in an internal data center using LDAP authentication against the internal Active Directory. For several reasons, we started moving different tools for DevOps teams to the cloud, Nginx, Harbor, the Atlassian Suite, etc. Exposing the Active Directory to the internet was not an option, so there was our internal Active Directory was in sync with an Azure Active Directory in the cloud, also used for external applications. Azure ID works as an OpenID Connect provider, and we already had several Kubernetes clusters running in other cloud providers, also using OpenID Connect with Azure. Also, one of our requirements was that all the applications were protected by an application gateway, so no API or endpoint is exposed to the internet without authentication. Let's start with the easy ones, the application supporting OIDC out of the box. So Kubernetes has an Auth plugin, you set it in the kubeconfig, that allows you to trigger OIDC directly from kubectl by opening an URL, you authenticate in Azure and enter a code, and that will add the ID token to your kubeconfig. Then the identity verification can be done offline. The signed ID token in the kubeconfig proves the user identity. The ID token also includes Active Directory groups, so bindings can be done. And for example, you can bind namespace permissions per group. Harbor also supports OIDC out of the box, but in the other versions, in the time of implementation, support was somehow limited. This is fixed now. For example, there was no group claim support. Now it's configurable. Harbor auto onboards users. That means that first time a user logs in, it is automatically onboarded, which is good. But the onboarding allowed the users to set its username, which is bad, because that is not homogeneous if you can set and change your own username. Also, the user claim was hard-coded, and the username claim in Azure Active Directory did not match the attribute with an Active Directory, but it had the full username, which was not good. So I worked on a pull request to fix the latter issues, and now with the latest version, you can skip the onboard screen and customize the username claim. Also, Jenkins and Atlassian Suite have OpenID support using different plugins. So to prevent exposing all the applications to the internet, which might lead to security breaches, even if they require internal authentication, all the requests were proxied through an Nginx load balancer. This Nginx would force OpenID Connect authentication before allowing any traffic. Once the user was authenticated, and while the Nginx session cookie was still valid, requests were proxied to the corresponding application. Please notice that both the Nginx load balancer and the internal application were both authenticating the user, but as the user was already logged in the OpenID Connect provider, Azure, there were just a couple of redirects in the browser, and the user could log in seamlessly. No need to enter the password or the credentials again. The details are complex, but basically Nginx supports OIDC in the Plus version using AuthJWT module and some JavaScript code, and a similar implementation exists using Lua for the open source version. I provide the links in the slide. There was an additional challenge in here. What happened to connections that were not HTTP? They could not use the browser cookies to verify if the user was logged in. For these connections, like for example SSH Git cloning, the user IP was whitelisted on successful login on Nginx, allowing the command line tools or similar to work transparently. And finally, what about the tools that did not support OpenID Connect? Fortunately, just a few. For example, the Sonatype Nexus repository. Well, we had to make some workarounds. Nexus didn't support OIDC, but it has an option for remote user token headers, where the user identity and groups can be provided in the HTTP request headers. As Nginx is proxying our request to Nexus, we can fill those headers from the ID token when proxying the request. And what about the user onboarding? The user must exist for root headers to work. So when the user does the OIDC login in Nginx, we run a small script and check via REST API if the user exists. If the user does not exist, we create the user using the API, and then we use the root headers. Other caveats that we found is, for example, the user migration. It's not trivial or even not possible to migrate the user from the old attributes in the Active Directory to OpenID Connect. Not just a matter of permissions, which can be automated or scripted, but for example, in Jira and Confluence, we wanted to preserve the user history, and that was not possible. Also, there are other things like non-standard ID token claims, depending on the provider. Some providers might not include some claims like the email. We recently had an issue in Sysdig Monitor and Secure integrating with an OIDC provider because the email was missing. Also, OpenID should be done over HTTPS. Public OIDC providers should have valid certificate, but if you are building your own infrastructure, please try to do things right and don't use self-signed or invalid certificates. Also, there is another very complex topic that is the single sign-off or single logout, because session handling is local to the application. If you log out of an application or you log out of the OpenID provider, the rest of the applications are not automatically notified. So you need to do some tricks to propagate the logout, like having an iframe or polling or whatever. And what about security? Well, it should be safe, and handling credentials more easily and all in one place is good for security. But remember, if those credentials are leaked, multiple tools are being exposed. So use additional measures like multi-factor authentication. Also, implicit run flow is not very popular because it's complicated and has some issues. And now there is a more modern flow, the proof key code exchange, that can be used for native or mobile applications. So to finish, let's recap. The good OpenID Connect is modern, easy to use, easy to implement, interoperable, flexible, widely supported, and can improve security and make your users happier while reducing help desk incidents. The bad, delegating credentials management to a single service can raise trust and availability, single point of failure issues. So take additional measures like high availability or protect the credentials with multi-factor authentication. And the ugly, well, some implementation and standards are not yet perfect, and some applications might not yet support OpenID Connect. So you might need to do some hacks and workarounds, but we like challenges, don't we? So thank you very much for assisting this talk, and now I'm open for your questions. Thank you very much. Hello, everybody. I'm Álvaro, so please, you can post or ask your question directly. And when the time ends, we can follow up on the Slack channel. So there are some very interesting questions. For example, Mark Collert pointed out in the questions that the implicit flow is deprecated and should not be used anymore. That's correct. I just showed a couple of examples of typical flows. The code flow, the first one, is a typical one for web applications, and the implicit flow is one which could be used for non-web applications, for example, for mobile applications. But as I already commented on some slides, it has some caveats, some security issues. So there is an alternative, the PKC, that is the proof key, proof key code exchange. It's a different flow where the untrusted application can generate a code and exchange, send a challenge to the OpenID provider, and then verify its identity without having to keep a secret like the code flow. Unfortunately, I am not 100% sure if all the OIDC providers support this flow, probably. Also, there are other flows, as some other people commented in the questions, like the client flow, that is intended to directly authenticate backend applications with OpenID providers without interacting with the users. And also there are other grant types, like, for example, supported directly by OAuth, not by OpenID. Like you can provide directly the user and password to the identity provider in the request that is sent from the backend. So in that case, for example, you could omit or don't require the redirect from the user to the identity provider and ask the password. But this is not safe, as you have to trust the application to keep the user password, right? The point of OpenID is to delegate the authentication completely to a third-party provider. So another question is, well, someone noticed that his provider, his other provider, is not sending the role and other necessary details in the token claims. Well, this is unfortunately one of the problems I found. There is not a standard of what are the claims that should be sent in the ID token. Some providers might include the groups or the roles, or they're not. And probably you can dig into your provider configuration and do some tuning in there to get the required claims, but sometimes it's really not possible at all. Okay, some other interesting questions. For example, someone is asking, how can I automate the testing of the authentication flow? Well, it depends what you want to automate. As far as I understand, you trust on the OpenID provider, and if what you want to check is that the behavior of your client application is correct, then you can try a mock OpenID provider and just do some automated testing, some unit testing or whatever, to verify that your application is sending the request correctly, handing the callback, and receiving the ID token and doing the corresponding verification. So also another question was why the auth token and the ID token are different. Well, I guess in here you mean the well, let me read the question. Okay, so really, OAuth is about authorization, not authentication. So usually using the OAuth, forget about OpenID, what you get is an opaque token, which is just a key that you handle to a third-party resource server to access some API or whatever. The difference with the ID token is that OpenID adds an extra layer, an extension over OAuth. So by specifying the OpenID scope parameter in the auth step, you also get the ID token, and the ID token has meaning. It is a JSON Web Token where you can find the user information and a signature, so you can verify. So probably the ID token can be used as the OAuth access token, I mean as an opaque token, but they are different, right? So, well, let me check how to use OIDC with a trusted party in such a way that it will not require so many redirects. For application, it is a problem with user experience as there are 3 redirects, right? As I told before, the point is you are delegating authentication, so you have to be redirected to the authentication provider. So the OpenID provider authenticates the user and gets back to you. You could collect the username and password or from your application and directly provide it to the OpenID provider using the password run type. But this is not recommended because the point of OpenID is getting rid of the responsibility of having to collect and managing the user and passwords. Okay, let me check some new questions we have in here. We are planning to use Azure Active Directory on on-prem Kubernetes cluster. Is the logout supported on Kubernetes dashboard? I really don't know. I know that Azure ID has a logout endpoint, so probably you could do something on your Kubernetes dashboard. So when you log out on the Kubernetes dashboard, it just redirects the user to the logout endpoint of the OpenID provider, and that could log out the user also. But logout is really tricky because you can log out from one application, you can log out from the OpenID provider. So in case the user is redirected to the provider, it gets asked for the credentials again, for authentication again. But it is not easy to have a global logout because all the applications that are already logged in, I mean, they only delegate the authentication of the user. The session management is managed by every individual application. So in order to have a global logout, you would need to coordinate all the applications first to log out from the provider when you log out from the application, and then you could need some kind of polling or notification mechanism so every application gets a notification or is aware that the user logged out. Okay, so what do you think about Keycloak for implementing OIDC? I haven't tested it thoroughly, but from what I know, it works correctly. I mean, it implements all the basic flows and everything, so it's a good OIDC provider. So how use OIDC for machine-to-machine authentication? For that, you have the client flow. Probably if you just Google OpenID client flow, there is a flow. I just showed a couple of them. There are others like the hybrid, the Pixie, the PKCE, etc. But the client-to-client flow allows directly to the backend to talk to the provider and perform the user authentication. And okay, let me check if I am missing anything. Okay, someone asked identity brokering through token exchange, is that not recommended? But I don't understand the question. Maybe if you can elaborate more, or we can follow up on the channel, on the Slack channel, because I don't really get what you mean in here. Okay, so I think that's all. All the questions are covered. Let me check. Oh, there is a second page in here. Sorry, Amy, there was a second page, but I don't know if we are out of time, right? So maybe we can follow up on the Slack channel. Please post just your questions in here, and I'll be glad to try to help you. Thank you very much, everyone.